Hi, now we're going to look at factoring some things. This is specifically for polynomials with 4 terms. All right, so because they have 4 terms, they will typically be cubic. They could be a higher power than that, but to have 4 terms, and if there's only one variable, it's often going to be cubic. So we're going to use GCF. So if you have not practiced finding GCF, you should really do that first, because we are going to use that concept twice in each one of these problems. So what we're going to do, in this case, we should always look at a polynomial and see if there's a GCF for all the parts. But what we're going to find here is there is not. Some of them have things in common, but they do not all 4 have anything in common. And so when that happens, what we're going to do with these polynomials with 4 terms is we are going to group them together, the first 2 and the second 2. So when I look at the first 2, now just for the first 2, what do they have in common? Yes, they both have x squared. So we're going to be dividing by that. So we would have x plus 7. Then we're going to look at the second 2, and we're going to see for these second 2, what do they have in common? Well, 2 goes into both of them. Now, whatever sign is right inside there, we're going to put that sign with the GCF in the middle. And then that's what we're dividing by. So in this case, we're going to divide by positive 2. So that leaves me with x and positive 7. And this is lovely, because now I see that we have a binomial that is the same. If that is not the same, do not try to keep going. Okay, something is wrong, like you messed up the signs, you didn't take the greatest common factor, something has gone wrong if those don't match. As long as they match, then we can basically factor that out. So what happens is the 2 things that are on the outside get pulled together in their own parenthesis. And once that happens, because they have x plus 7 in common, that only has to be written once, because we're using the parentheses around the x squared plus 2. And then to check my answer, I can distribute. Okay, now it's a 2 by 2, so we could use FOIL or just distribute left to right. So if I distribute x squared times x, x to the 3rd, x squared times 7, 7x squared, 2 times x, 2 times 7. Lovely, right? All right, so that's our process, and I'm gonna show you a couple more. Make sure I show you one where we have a negative in that 3rd position, but I'm going to try my best to kind of keep this video a little shorter. So let me look at number 3. All right, so I'm looking here at number 3. I'm going to make this a little bit bigger just so that we can really see that well. So again, nothing goes into everything. So I'm going to group them, first 2 and second 2. And when I look at those first 2, what do they have in common? W to the 2nd power, yes. So I'm dividing both of the first 2 by that. That leaves me with W plus 5. Then when I look at the second 2, I see this negative. I don't ever want a negative sign like next to the parenthesis on the inside like that. And so I'm going to divide them not just by the 8 that they have in common. I'm going to divide them by negative 8. So they're both getting divided by negative 8. It's not just that I bring down the negative sign. I'm actually dividing both terms by negative 8, not just the first one. It's important because if I don't divide by a negative, I would have minus 5, and that would not match. Instead, two negatives, 40 and 8, both negative, make positive 5. So my parentheses match. Since my parentheses match, I can pull together what is on the outsides, w squared minus 8. And then once that's pulled together, I only need to write the common factor, the common binomial factor, one time, because with the parentheses, it means the w squared gets multiplied by both and the negative 8 by both. The distributing it out is simply a check. And so you wouldn't necessarily even have to write it, but I would encourage you to go through that process. So maybe it's just something you think. W squared times w, w to the third. W squared times 5. 5w squared, I like where this is going. Negative 8 times w, negative 8w. Negative 8 times 5, negative 40. Perfect, right? Okay. So far we've only had cubics, so they've just had third power. Let's take a quick look at number 5 because it has a higher power. You won't see very many with higher powers, but I want to at least do one here for you that does have a higher power. So again, group those babies together, first two, second two. Looking at the first two, this time they actually have p to the third in common, and they're left with p squared minus 6. So I'm just doing GCF for the first two, GCF for the second two, but if that one in the first position of the second two, or the third term, if it's negative, we're going to use negative for a GCF. So I'm using negative 2. When I divide them both by negative 2, I get p squared minus 6. My two sets of parentheses match, so I've got a common binomial factor, so I can bring together what's on the outside into one binomial, which allows me to write this in a shorter way as p squared minus 6. And if we multiply that out and distribute, we see that we do get that same polynomial that we began with. All right, I'm not seeing an example that does this in the notes, but I want to be sure that I show you that sometimes this actually happens in number 6 and number 9. So I'll show you number 6. This is on the homework page, all right? But sometimes there will be a pair without a common factor. And let's see how we handle that. So I'm going to group these together. When I group them together, these first two, they also have numbers for the first time for the other examples. They both have a 2 in common, and they both have a squared. What that leaves me with is 5a plus 2. And then when I look at the second two, 5a and 2 don't have anything in common, but we can always divide by 1. So this is the one time we're going to use that 1 as a greatest common factor. And so we're going to write it out here as plus 1. And then it's still 5a plus 2. It is important that we have that 1 because we should still have two binomials as our answer. Pardon me. Pull together what's on the outsides. If we don't write the plus 1 and then we try to check it, we would only get the first two terms. We would not have that whole polynomial. So that also, something similar to that, happens in number 9. Also in number 9, they can have numbers, but only have a variable in common. And then the second part of that, again, these two don't have anything in common, so just plus 1. And then from there, you're just pulling things together. All right, I hope that's helpful. And that, again, is factoring by grouping. We use that when we have polynomials with 4 terms.